Hi everyone. Now we are going to discuss about another one transistor circuit. Here we are going to find the collector feedback resistor to make the operating point at the center of the load line. To draw the load line, let us apply the KVL rule at the output side of the transistor. If we apply the KVL rule, we will get below expression. That is VCE is equal to VCC minus IC into RC minus IE into R. Here, a transistor operating in active region, so that IC is approximately equal to IE. So that VCE is equal to 15 volt minus IC into 4.2K plus 1.K ohm, which is equal to 15 volt minus IC into 5.7 kilo ohm. To draw the load line, we need at least 2 points. We can point to extreme point by applying the IC and VCE as 0. If we apply the VCE equal to 0, we will get maximum value of collector current, which is equal to 15 volt divided by 5.7 kilo ohm. When we simplify this, we will get 2.63 milliamps. Similarly, when we put collector current IC equal to 0, then we will get maximum VCE, that is equal to 15 volt. So now let us draw the load line. Here we are consider y-axis as IC and x-axis as VCE, and we have identified the two extreme point. One is IC and another point is VCE. So as we discussed earlier, we have to calculate the operating point at the center of the load line. If you consider center of the load line, the current IC should be 1.36 milliamps and the collector to emitter voltage VC will be 7.5 volt. For the given circuit, the operating point such that VCE is equal to 7.5 volt and IC will be 1.36 milliamps. So now we have to find the base resistor value. To find the base resistor value, we have to put the KVL rules at input side of the transistor. So that when we put the KVL rule at the input side of the transistor, the expression will be 15 volt minus IC into RC minus IB into RB minus VBE, which is base to emitter voltage for this current transistor, and IE into RE, which is equal to 0. By considering the current transistor, the voltage across the base to emitter VBE will be equal to 0.797 volt, and also we know that IC is approximately equal to IE, and we can consider base current IB is equal to IC divided by beta. If you put this value in above expression, we will write it as 15 volt minus 0.797 volt is equal to IB into RB plus IC into RC plus RE, that is equal to 14.2 volt equal to IC divided by beta into RB plus 1.36 milliamps into 5.7 kilo ohm, which is equal to 14.2 volt minus 7.75 volt equal to 1.36 milliamps divided by 100, because here we have considered current gain of the transistor beta will be 100 into RB. So that resistor RB is equal to 6.45 volt into 100 divided by 1.36 milliamps, which is equal to 474.26 kilo ohm. That means whenever the value of base resistor is 474.26 kilo ohm, the operating point of the transistor will be center of the load line. Let us verify this in the circuit. So here I'm going to put the value of 474.26 kilo ohm. Okay, let us run the simulation. If I verify the collector current, that will be 1.36 milliamps, and the voltage between the collector to emitter will be 7.2 volt. Hope we are able to understand how to calculate the base collector feedback resistance to conclude the operating point of the transistor circuit. I request you to kindly subscribe and like the video. Thank you. Thank you for the watching.